Hey students, these are notes for section 9.2, and in this section we're going to do one sample z-test for proportions. We're going to later talk about means, but right now we're looking at just proportions. In these examples, we're looking at either a one-tail test, or with the right tail, left tail, or both tails. In this one, the hypothesis is that the true proportion is greater than the null proportion, or the proportion we thought it was. And this says the true proportion is actually less than the null proportion, or proportion we thought it was in the beginning. And this is not equal to. So whenever it's not equal to, we have to test on both ends. Essentially, you're going to find the area of 1 and then just double it. And that will give you that proportion. All right, so before you begin, or at some point within the problem, there's 4 steps you have to do. You have to state the null and state the alternative hypothesis. You have to decide what the significance level is. If they don't tell you, we're going to assume it's a 95% confidence level or a 5% significance level. We're going to decide what parameters are. We're going to make a plan. We're going to state what our plan is and what we're doing. We're going to perform the appropriate calculations, as in check to see whether or not it's random, all that stuff's still true. Checking whether or not it's actually normal, that's still true. And check whether or not it's independent, all that stuff's still true. Now, after we get done with all that, we're going to actually use this formula to find that z-score, and then we can calculate the area. And the way we've always found the area using z-score. We're going to write our conclusion about our results once it's done. All right, that's the mission. Now let's actually get to it. So here we are. All right, this is for example at a school called Dawson High School. All right, it says back to the Dawson example. Recall the problem. Dawson schools are proud of the fact that they have many students of many diverse backgrounds. You decide to test this claim. According to the Center of American Progress, you find that 30.6% of Coloradans are people of color. If Dawson were a school that randomly chose students from the Colorado population, it should have close to that proportion of students of color. You set up a test to check the hypothesis. All right, we're going to check all that stuff about no and state and so forth. Let's get started with this. Let's start with my null and my alternative hypothesis. My null is that the proportion is actually equal to 0.306. Proportion of students at Dawson is actually about 30.6% students of color. And the alternative is that portion isn't true. So we're going to say proportion is something less than 0.306. All right, so that's my state part. So we're going to state before we begin. Let's get some things out of the way. They said that the significance level is 5%. So A is 0.05. And they gave us some other information as well. They said you decide to test this claim. You got a simple random sample of 50 students from Dawson, and you found that 12 of them identified as with a race or ethnicity other than Caucasian, as in people of color. So I know that P hat is 12 out of 50, which is 24%. So I got my significance level decided, and I got my P hat value decided. They said it's a simple random sample. So if we check and see if it's random, that's a yes. To be normal, we got a simple random sample of 50 students. And just by the central limit theorem, this should be a normal distribution. So that's true. It's independent. That relates to the 10% rule. And that's it's n times the population proportion should be greater than or equal to 10. So 50 and the population proportion is 0.306. And that's going to be greater than or equal to 10. And if I plug in my calculator, that's basically a third of 50, which is going to be bigger than 10. So that part is also true. If this is a non-multiple choice part, so a short answer, we need to write our plan. We're just going to say our plan is we will be performing a one-sided z-test for a proportion as long as the conditions are met. And we just looked at the conditions, and all the conditions were met. So from there, let's actually do it. So let's actually get to the math. So now all that's done, we actually do what we came to do. All right, so what we know for certain is If I made a bell curve, what I do know, I know I assume population proportion is 0.306, and I know that our p hat value is something less than that, which is 0.24. And I really want to know the probability, what that z-score is there, so I can actually calculate it. And that z-score is given at the front of the page, the front of the section, and it's written as this formula. So we got the p hat, take away the proportion that was given that is assumed to be the p null, and then divided by all those values. Let's get to it. So it should be z should equal to 0.24, take away 0.306, divided by the square root of 0.306 times 0.694 over 50. And if you do the math there, I'm going to type in my calculator now. So my calculator says it should be about negative 0.10127. So that would be that z-score. And I can find that with my calculator or from a z-score table. So I'm going to use it with my calculator. So you find that area. All right, so that normal CDF is about 15.6%. So it's about, that area should be about 0.15. I'm going to round it about 6. So that's about a 15% chance of that actually happening. And given a significant level of 0.5, this is definitely bigger than 0.05. So we're going to say that this is very likely to occur. I mean, it's not unusual to occur. So in this case, we will fail to reject the null. All right, so here's our conclusion. Since 15.6% is greater than our significance level, we fail to reject the null. This means that we don't have enough statistical evidence to say that Dawson has a lower percent of people of color than the state of Colorado. Let's go to example 2. Example 2 says that according to the CDC, 50% of high school students have never smoked a cigarette. Keena wonders whether this national result holds true for high school. For AP Stats class project, she surveys a simple random sample of 150 students from a high school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Keena conclude? So let's first get this out of the way. Our proportion, this according to the CDC, is 50%, or 0.5. And our p hat value is 90 divided by 150, which is about 0.6. So what we know is that our hypothesis is that the true proportion equals the 50%. Our alternative hypothesis should be the true proportion is not 50%. In this case, we're going to do a double-sided test, because in this case, it could be less than 50%, or it could be greatly more than 50%. So we're going to look at both ends, and when we actually test this hypothesis. All right, with that said, we also know that n equals 150, and we also know that our standard deviation for p hat should be the square root of the proportion, which is 0.5, times 0.5 times, we're divided by 150, which is about 0.0408. So we know that should be our standard deviation of it all. And we're going to test for our state, plan, all that stuff in just a moment. I just want to get an idea of what we're looking at first. What we know is that the proportion should be about 0.5. Our average proportion, our mean proportion, should be about 0.5. And what we found was our mean p hat, this one sample we took, was actually 0.6. So it could be greater than 0.6. Or we can look on the left end, on the other tail, whatever this area is, we just multiply by 2 to know the area on the opposite side. So let's figure out this area here. We're going to need that z-score formula from earlier, which is p hat, take away the p null, and then that standard deviation below. So that area that z-score, should be 0.6, take away 0.5, divided by the standard deviation that we just found, 0.0408. Plug the calculator, do the math for it, you should find that that standard deviation is about 2.451. So that z-score should be about 2.451. So if I actually use my calculator to find the area, I go to normal CDF, and now my upper bound is going to be something large. My lower bound is going to be 2.451, and the upper area is about 0.007. So this area, our probability, is 0.007. And that means this is also 0.007. If I double 0.007, that is 0.007 times 2, which is about 0.014. So that probability should be 0.014. So they have a probability that is z being greater than 2.451, or, all right, so find the probability that z being greater than 2.451 is equal to 0.007, and the probability that our p-value is not equal to 50% is twice that, so 0.014. This number is, they didn't give us a significance level, so we're going to assume it's 95% confidence, so we can assume our significance level is 0.05. So this value is smaller than 0.05. In this case, we have to reject the null. So we can say that we're pretty certain that the null hypothesis that 50% of students in high school smoked is not true. So it's not actually equal to it. So let's write our conclusion. So if we were done, we would conclude that since 1.4% is less than our significance level of 5%, we can reject the null hypothesis that 50% of students have never smoked a cigarette in high school. So it could be more, it could be less, but we know that that's not really true. But we wrote the conclusion before we actually did our test. And we did our state portion. So here's our state. But we didn't actually check to see if it was random, if it was normal, and if it was independent. So let's go back to the question. Let's make sure this is true. They said it was a simple random sample. So the random section is checked off. In the sample, we had 150 students that were chosen randomly. So for that reason alone, it has to be normal considering the central limit theorem. And there's an independent, and that's again testing whether or not the 10% rule applies. And in this case, our value of n times p has greater than or equal to 10. So in this case, it's 150. And that p-value was 0.5. And 150 times 1/2 is definitely bigger than 10, because that's 75. So that portion is also true. So if we went back and we checked to see all that was true, that was true. And we should have said our plan was to conduct a two-sided z-test for proportion. Hence, we had a not equal to symbol, and we test both ends. And so we took one area and doubled the other. But that's what we do, and that's how we actually solve a problem like that. Hopefully you find it easy. We'll talk more about that in class today. All right, talk to you soon. Good luck.